Okay, class. So this is a slinky, a long spring that I was mentioning about, and we can show the propagation of sound through air using a slinky. ठीक है? If you assume कि ये जो slinky का length है, ये air molecules हैं सारे, ठीक है? और यहाँ से suppose speaker की आवाज आनी शुरू हो रही है. Okay? Suppose from this end, the speaker is sending the vibrations. ठीक है? तो स्पीकर का जो आपने एज आई मेंशन जो डायफ्राम है वो आपको दिखता होगा, वो वाइब्रेट करता है जब साउंड प्रोड्यूस होती है उसमें से. ओके, इनफैक्ट व्हेन यू स्पीक, इफ यू कीप योर हैंड नियर योर थ्रोट, यू कैन फील द वाइब्रेशंस इनसाइड. जब आप बोल रहे होते हैं, आपको भी अपनी विंड पाइप के पास यहाँ नेक में आप देखेंगे, यू कैन फील द वाइब्रेशंस. ओके, सो दिस इज द रिप्रेजेंटेशन ऑफ द एयर मॉलिक्यूल. और जब साउंड प्रोपोगेट करती है थ्रू एयर, तो हम ये कह रहे थे कि यहाँ से एकदम से वो पुश आएगा, और वो पुश आगे कैसे ट्रैवल करता है साउंड का, वो ऐसा दिखेगा. वो जो सडन पुश आता है एक कॉर्नर से, वो ऐसे ट्रैवल करता है आगे. ओके, अब ड्यूरिंग दिस वेव दैट आई हैव प्रोपोगेटेड थ्रू दिस लिंकी, इफ अगर आप ध्यान से देखें, इफ यू लुक एट इट वेरी केयरफुली, यू विल फाइंड दैट देयर आर सम पोर्शंस जहाँ पे ये स्ट्रैंड्स एकदम से इकट्ठा हो रहे हैं, क्योंकि ये टू एंड फ्रो मोशन कर रहे हैं अपने पोजीशन के अबाउट, मेन पोजीशन के अबाउट. तो वहाँ पोजीशंस हैं, कुछ ऐसे पोर्शंस आते हैं जहाँ ये स्ट्रैंड्स एकदम से ऐसे कंप्रेस हो जाते हैं, और कुछ ऐसी पोजीशंस आती हैं जहाँ ये स्ट्रैंड्स एकदम से फार अपार्ट होते हुए दिखती हैं, क्योंकि यहाँ से एक पुश आया है. ओके, तो वो जो पुश यहाँ से ट्रैवल कर रहा है, वो कंप्रेशंस यानी कि यूँ इकट्ठे हो जाती हैं स्ट्रैंड्स, और रेयर फैक्शंस यानी कि गैप्स आ जाते हैं, उनमें ट्रैवल कर रहे हैं. जब एयर में साउंड ट्रैवल करती है तो वो भी इसी तरीके से ट्रैवल करती है. ठीक है, कंप्रेशन और रेयर फैक्शंस की फॉर्म में. ओके, इट्स अ लॉन्गिट्यूडनल वेव. रिमेंबर, साउंड इज अ लॉन्गिट्यूडनल वेव एंड इट ट्रैवल्स सच दैट द पार्टिकल्स ऑसिलेट पैरेलल टू द डायरेक्शन ऑफ द वेव प्रोपगेशन. वेव इस डायरेक्शन में जा रही है, पार्टिकल्स भी इसी डायरेक्शन में टू एंड फ्रो ऑसिलेट कर रहे हैं, वाइब्रेट कर रहे हैं. ओके, the same I have represented here diagrammatically. This is the relaxed spring, या फिर आप ये कह सकते हो this is the mean position of the air molecules जब कोई साउंड प्रोड्यूस नहीं हो रही. और जब साउंड प्रोड्यूस होनी शुरू होती है तो ये कंप्रेशंस और रेयर फैक्शंस बनने शुरू हो जाते हैं, क्योंकि साउंड जहाँ से प्रोड्यूस हो रही है वो बॉडी वाइब्रेट कर रही होगी, और वो वाइब्रेटिंग बॉडी पुश कर रही है या एनर्जी ट्रांसफर कर रही है एयर मॉलिक्यूल्स को इन दिस मैनर. ओके, बाय वाइब्रेटिंग टू एंड फ्रो अबाउट इट्स मीन पोजिशन. सो एयर मॉलिक्यूल्स का कॉलम ऐसा दिखता है. जब स्पीकर से साउंड आ रही है, एयर मॉलिक्यूल्स का कॉलम भी ऐसे ही ऑसिलेट करने लग जाता है. ठीक है, इट ऑल्सो रिप्रेजेंट्स द वेरिएशन इन द डेंसिटीज ऑफ द एयर. एक जगह पे सडनली मॉलिक्यूल्स इकट्ठे हो गए हैं, उसको हम कंप्रेशन कह रहे हैं. एक जगह पे मॉलिक्यूल्स के बीच में गैप आ गया है, उसको हम रेयर फैक्शन कह रहे हैं. ओके, सो आई हैव मेंशन्ड दैट कंप्रेशन एंड रेयर फैक्शन. Okay, so you can clearly see here that when we strike a tuning fork to the rubber pad and we bring it near this light ball which has been hung with a thread, you can see very clearly that the vibrations of the tuning fork are passing their energy to that ball, and the vibrations can be clearly seen made by the ball itself. So that shows it is a vibrating body. The tuning fork is a vibrating body which was creating that ting sound. Okay, all right, so this part here is representing propagation of sound through air. Propagation of sound through air. कंप्रेशन एंड रेयर फैक्शंस, या ये जो डेंसिटी में चेंजेस आ रहे हैं, या जो हमने कहा था स्पीकर धक्का देगा मॉलिक्यूल्स को और वो एक जगह इकट्ठे हो जाएंगे और एक जगह से मूव कर जाएंगे, और मॉलिक्यूल्स अपनी अपनी जगह पे वाइब्रेट करते हुए एनर्जी आगे पास करेंगे. दिस इज द कॉन्सेप्ट ऑफ प्रोपगेशन ऑफ साउंड इज सेम इन सॉलिड, लिक्विड्स एंड गैसेस. बट जो यहाँ हमने डायग्रामेटिक रिप्रेजेंटेशन दी है, दिस इज फॉर प्रोपगेशन ऑफ साउंड थ्रू एयर. एंड रिमेंबर, sound cannot travel through vacuum. Reason is this only. Sound needs a material medium to propagate. Sound is produced by vibrating bodies, but वो जो vibration है उनकी energy को transfer करने के लिए from one point to the other, it needs a medium, एक जरिया चाहिए उसको, so that medium can be either solid, liquid or gas, but in vacuum sound cannot travel. Okay, there has to be somebody to pass on this push that is coming from the speaker or the vibrating body to the other particles. Okay, class, so just take a look at the setup that has been shown. There is a bell jar that you can see, a glass jar which has an electric bell already fitted inside it. The connections of the bell are all outside the jar so that we can turn and on and off as and when required. And there is this vacuum pump which has been labeled in the video as well, which can be used to create a vacuum inside the bell jar. Okay, so when we turn on the bell, just observe and try to hear the sound, and when we turn on the vacuum pump, observe the difference that you notice. So you can hear the bell loud and clear, and the vacuum pump is turned on. So I hope all of you could clearly notice that the sound of the bell was loud and clear, and as soon as the vacuum pump was turned on, it removed all the air from inside the bell jar, and hence the sound of the bell is now gradually decreasing, and it is no more heard once maximum amount of air is removed from the bell jar. Okay, so this clearly concludes that once the medium inside the jar has been removed, the sound can no more travel. I am not saying the sound is not being produced. Bell is ringing, the hammer is continuously hitting the gong that is there in the electric bell. But even after hitting it at the same pace, the sound is not traveling through the jar outside so that we can hear it. Okay, so that is an experimental demonstration to show that sound needs a medium to propagate. Okay, I hope all of you could understand and comprehend the video. So this is the write-up of the famous bell jar experiment that we just demonstrated via a video. The aim you are mentioning as to show that sound needs a medium to propagate. Okay, apparatus or the material required would be a glass jar, an electric bell, a battery, switch, and a vacuum pump. Okay, also we'll require a cork to make it an airtight container. Okay, so just mention this wooden piece or a cork which helps us to make it an airtight container. Okay, so the procedure would include the diagram, and then you will be writing the procedure in these three brief steps. First is arrange the setup as shown, switch on the circuit, and the bell can be heard clearly. Then observe after switching on the vacuum pump. Okay, then will come your observations, that what have you observed when you switch on the vacuum pump. Okay, so your observation will be, as the air is gradually removed from the jar, the sound of the bell becomes feeble, and your conclusion will be that sound needs a medium to propagate. Okay, conclusion to the experiment: sound needs a medium to propagate. What our aim was, we have demonstrated. Okay, so this is the answer to the question if you are asked to list an activity to demonstrate that sound needs a medium to propagate. Okay, so class, sound if we have to represent it as a graphical wave, what we can do is we can plot the graph between distance that the wave is traveling on the x-axis and the displacement that the particles of the medium are suffering on the y-axis. Now on the x-axis, you can either plot the displacement of the particles with distance, or you can also plot it with time. It can be plotted against distance, or time can be plotted on the x-axis, depending upon what we are trying to represent. Okay, now remember, here on the graph, this 0 point is referring to the mean position of the particles of the medium. Okay, this 0 line is referring to the mean position of the particles of the medium. When the disturbance starts or the wave starts, the particles move from their mean position, they reach a maximum, then come back to their mean, reach a minimum, and this continues till the wave travels. Okay, this will continue till the wave travels. We have defined this maximum displacement of the medium particles from their mean position as the amplitude of the wave. This is the first term that we had defined, the amplitude of the wave. We represented it by capital A. It is the maximum displacement, okay, of the medium particles from their mean position. Maximum displacement of medium particles from their mean positions. Now, since it is the maximum, the particles are shifted from their mean positions. The SI unit for amplitude can be meters. Okay. But we had also mentioned, in case of sound, when the medium particles are moving from their mean position, they are getting displaced from their mean position. In that case, the amplitude can also be measured in terms of pressure or density of the medium. In case of sound, the units of amplitude can be those of density or pressure. Okay, we will be discussing why density or pressure can also be plotted on the y-axis in the coming parts of the chapter. For now, you can remember that it is the maximum displacement of the medium particles from their mean position, and it is measured in meters. In case of sound, the units can be those of density or pressure. In detail, you will be discussing this point in class 9th when you are again going to study this chapter. Okay, there is an extension to this chapter in class 9th. So this particular point will be more clear then, but still we will be discussing it once as we proceed with the chapter. So that is how we had defined amplitude. Then we have defined the wavelength of the wave. Wavelength को कैसे define किया था हमने? The distance between two consecutive crests or two consecutive troughs. Crest और trough हम किसको कह रहे हैं? ये जो peaks आ रहे हैं, ये crest हैं, और ये जो dips आ रहे हैं, ये troughs हैं. Okay, so distance between two consecutive crests or two consecutive troughs is labeled as the wavelength of the wave. Okay, wavelength का symbol हमने lambda बनाया था. We have discussed this in the last class again. Okay, so first was amplitude. Okay, the second term that we had defined was wavelength. Now, since it's a length, it will be measured in meters. Okay, it has a unit, SI unit as meters. So I'll be just mentioning about wavelength here. Second term that we had defined is wavelength. Symbol is this, we call it lambda. Okay, and it is the distance between two consecutive means one after the other, the next one. Okay, two consecutive crest or troughs. Now since it's a distance, we measure it in meters. Okay, so this is the wavelength. जो दो मैक्सिमाज हैं या दो मिनिमाज हैं उनके बीच के गैप को हम वेवलेंथ कहते हैं. Or you can say it in this way, in simpler terms you can call it कि one particular wave जब complete हो जाती है, the distance it covers is wavelength. Okay, we call this as one wave, from one maximum to the original value to minimum, back to the original value, and again reaching the maximum. This is one wave. Okay, or you can also define it the other way, from one minimum, original value, maximum, original value, again a minimum. Okay, this is also one way. Or the third way of defining it is going from its mean value, reaching a maximum, coming back, reaching a minimum, coming back. So this is also representing single wave. So these are the three ways in which we have labeled or we have understood when we say one wave is completed. Okay, either you say from one maxima to minima again to maxima, this is one wave, या फिर from one minima to a maxima to again a minima, or you call this a wave, या फिर starting from the mean, going to a maximum, then to a minimum, and coming back to the mean value, original value, we call this a wave. So distance traveled during this time is wavelength. Either you call it distance between two successive peaks or crest, or the distance between two successive troughs. That is what we call as a wavelength. So the third term that we are going to define for a wave is time period. Again, you are familiar with this term since class 7th, where you have defined time period for a pendulum, simple pendulum, and you had defined it as the time it takes to complete one oscillation. Yes, the time the pendulum takes to start from the original position, go to the other extreme, and come back to the original position, you call it time period, or you say that it has completed one oscillation. Now that is what is represented here also. Time period will be the time taken to complete one oscillation. Oscillation of what? Oscillation of the medium particles. Okay, particles are oscillating. They are rising from their mean position, they come back, they go to the other minimum, and then they come back. So this is one oscillation of the particles of the medium. So time period is time taken to complete one oscillation. Time taken to complete one oscillation. Okay. And since it is the time taken, so the SI unit will be seconds. SI unit of time is seconds. So represented by a small s. Okay. So time taken by the wave to complete one oscillation, ये जो wavelength जितना distance है, वो wave ने कितनी देर में cover किया है, उसको हम time period कहते हैं. Okay. या फिर आप ऐसे कह सकते हो, the time interval between two consecutive crests or two consecutive troughs is known as time period. Okay. The time interval between, I am writing the alternate statement also, or the time interval between two consecutive crest or troughs. Time period between two consecutive crests or troughs is also known as the time period of a wave. ठीक है, मतलब लैम्डा जितना डिस्टेंस, वेवलेंथ जितना डिस्टेंस वेव कितनी देर में कवर करती है, दैट इज नोन एज द टाइम पीरियड ऑफ अ वेव. Okay, and the reciprocal of this time period is the frequency of the wave. Okay, so till now we have defined amplitude, wavelength, and time period, and now using time period we are going to define the frequency of the wave. Okay, class, I again repeat, frequency, which is denoted by this symbol nu. Okay, it is defined as the number of oscillations per second. कितनी oscillations wave एक second में complete करती है. So the formula, mathematical form is number of oscillations upon time taken. or we can simply write it as 1 by time period. Number of oscillations जब 1 होती हैं तो time taken time period जितना होता है. So we can rewrite the formula as 1 upon time period or number of oscillations upon time taken. The SI unit is hertz. Second inverse बन रहा है SI unit 1 upon second, हम उसको hertz कहते हैं. It has been named after a physicist. So we are writing H in small letters when we are writing the complete word, and when we are only giving the symbol, we write H capital and Z in small letters. So that is frequency, how frequent a particular event is. And what event we are talking about here is the oscillations of the particles. So कितनी oscillations एक second में cover हो रही हैं, that is known as frequency. How many oscillations per second means frequency. A sound wave completes 200 oscillations in 10 seconds. You have to find its time period and frequency. So we go by the normal unitary method that we use, that if 200 oscillations are taking place in 10 seconds, so one oscillation will take place in how much time? 10 divided by 200, which is equal to, if I cancel out these zeros, I am left with 1 by 20 seconds. So that is the time period. Okay. So 20 oscillations are in 10 seconds. One oscillation will take time 1 by 20 seconds, and I will give the representation in decimal. So how much is 1 by 20 in decimal? All of you to calculate. I again repeat. So time for 200 oscillations is given as 10 seconds. Time for one oscillation we are calculating, that will be 10 by 200. When I simplify this, becomes 1 by 20 seconds, which in decimal is 0.05 seconds. So this is the time taken to complete one oscillation. We represent it with capital T, or the time period of the wave. Now, how is time period and frequency related? Frequency, I told you this is the symbol for frequency, is also calculated as 1 by time period. Okay. So when I do that, 1 upon time period would be 1 upon 1 upon 20. So what does that become? That becomes 20 hertz. Remember the unit of frequency? 20 hertz. That means this particular sound wave is completing 20 oscillations in 1 second. Okay, that is what the meaning of the statement is. Frequency being 20 hertz means that 20 oscillations are being completed in 1 second. 20 hertz is 20 per second, 20 oscillations per second. Okay, so that is the frequency of the wave, 20 hertz, and that is the time period of the wave, 0.05 seconds. Okay, so time for 450 oscillations this time is given 40 seconds, and you have to find the time period and frequency again. So similar question, just change the values. So time for 450 oscillations is equal to 40 seconds. T for one oscillation will be 40 divided by 450. Okay, so this 0 is gone, and 4 by 45 seconds is what we are getting as the time period. 4 by 45. How much is this in decimals? So dividing 4 by 45, we are getting time period as 0.08 seconds. It's a non-terminating decimal, we'll leave it at the second decimal place. Now calculating frequency as 1 by time period. So that will be 1 divided by time period. I am again using the fraction form because that is easier to comprehend and easier to calculate. It's a non-terminating decimal. इससे अगर हम divide करते हैं तो आंसर हमारा थोड़ा सा अलग आ सकता है, क्योंकि एक नॉन टर्मिनेटिंग डेसिमल को हमने टर्मिनेट करके यूज करा वैल्यू में. ओके, आंसर विल बी स्लाइटली डिफरेंट इफ यू कैलकुलेट इट एज 1 by 0.08. It won't be considered wrong, but yes, it will be a bit different from the actual answer because it's a non-terminating decimal. ये आंसर में हम कैलकुलेट करने के लिए वैल्यू 0.08 अगर डालेंगे तो आंसर हल्का सा अलग आएगा जो एक्चुअल आंसर है, बिकॉज इट इज अ नॉन टर्मिनेटिंग डेसिमल. आइडियली हमें वैल्यू कैसे कैलकुलेट करनी चाहिए? 1 डिवाइडेड बाय 0.088888. हम इतनी अनएंडिंग डेसिमल्स प्लेसेस तक नहीं जाएंगे. We'll restrict ourselves, so better we'll calculate it as 1 upon 4 by 45. What will this become? This becomes 45 by 4. And how much is that? 45 by 4. 11.2 hertz. Okay? 11.2 hertz. So that is the frequency of this sound wave. We can write it in the second decimal also. It will be 11.25. So that is not an issue. Okay? But try not to go beyond second decimal in any of the cases. यहाँ पे तो the calculation is over at the second place, but otherwise also it's better you just keep your numbers in the calculation till second decimal place. Alright class, so frequency we have calculated in both the numericals as 1 upon time period. But remember, we can also calculate frequency as number of oscillations per unit time. So frequency को हमने ऐसे भी define किया था, number of oscillations upon time taken. तो आप ऐसे भी calculate कर सकते हो. That is an alternate method. Okay, what do I write here? Number of oscillations are 450. Divided by time taken for these oscillations is 40. So 45 by 4. We come to the same step again. Okay, it's just the representation is different. The formula that we are writing looks different, but it means the same. Frequency को या तो 1 by time period आप calculate कर सकते हो, या फिर you can calculate it as number of oscillations per unit time. एक सेकंड में कितनी oscillations होती हैं? That is what is meant by frequency. Okay, so this is question number 6 from your NCERT back exercise, page 169. It says that sound from a mosquito is produced when it vibrates its wings at the average rate of 500 vibrations per second. 500 vibrations per second देने का क्या मतलब है? This is the frequency given to you in the question. Okay. Now you have been asked, what is the time period of vibration? Frequency is given in the question, 500 vibrations per second. Okay, and you have to find the time period of these vibrations. First of all, I would again repeat, how do we know this is frequency? Okay, so class, in this question, I again repeat, the frequency is given 500 vibrations per second, number of vibrations per second. That is how we define frequency. So we got to know कि question में ये frequency given है, number of vibrations per second given है, ठीक है? अब frequency given है question में 500 vibrations per second को आप 500 hertz भी लिख सकते हो. It is one and the same thing. 500 vibrations per second मतलब 500 hertz. Time period आपको calculate करना है और time period का formula क्या है हमारे पास? 1 by frequency. ये दोनों एक दूसरे के साथ reciprocal में related हैं. Okay? So time period is 1 by frequency. So that will be 1 divided by 500 seconds. Okay? And when we solve this 1 divided by 500 seconds, what do we get? What will be the decimal representation of 1 by 500? Okay, so when we divide 1 by 500, we get 0.002 seconds. इसका मतलब है एक वाइब्रेशन, मतलब विंग जो फ्लटर कर रहे हैं मॉस्किटो के, एक वाइब्रेशन खत्म हो जाती है कितनी देर में? 0.002 seconds में, very small time. That is why it is able to make so many vibrations in 1 second. 500 times वो अपने wings को flutter कर रहा है 1 second में. So can you see the speed at which the fluttering is happening? Okay, so frequency being 500 vibrations per second or 500 hertz means that the time period of oscillation or vibration is 0.002 seconds. Very small time it is taking to complete one vibration, and hence it is able to complete 500 vibrations in 1 second. So in this case, you have been given a sound wave and you have been asked that what is the time period, frequency and amplitude of the wave shown. Okay, and here is the wave graphical representation given to you. The y-axis is showing you the displacement in meters and the x-axis is showing you the time in seconds. All right, and this point, the height is mentioned as 5 meters. Okay, and these time intervals I have mentioned here, 0, 0.1, 0.2, 0.3 and so on. You have to identify, just looking at the graph or the sound wave representation or the wave representation for that case, you have to simply look at the graph or the representation given and find the time period, frequency and amplitude of the wave. Okay, so class, here a sound wave or wave representation is given to you, and you have been asked to find the time period, frequency, and amplitude of the wave. Okay, so looking at the graph, you can see the maximum the particles of the wave are displaced from their mean position. This represents the mean position, and the maximum they are displaced from the mean position represents the amplitude. So amplitude here clearly is 5 meters. Okay, just looking at the graph or the diagram you can make out. Then comes, what about the time period of this wave? Time period means how much time the wave is taking to complete one oscillation. And how do we define one oscillation? We start from the mean value, go to the maximum, come back to the mean value, go to the minimum, and again come back to the minimum. This completes one oscillation. Okay, this is one way of defining one oscillation. So how much time it has taken to complete this? You can clearly see it on the time axis. The time taken to complete this one oscillation is zero point 0.2 seconds. Alright. And then comes the frequency. How many oscillations is this wave completing in 1 second? How do we know that? यहाँ 1 सेकेंड तक अगर ये वेव प्लॉट होती तो हम काउंट कर लेते कि कितनी ऑसिलेशन है. अभी 1 सेकेंड तक प्लॉट नहीं है, प्लॉट सिर्फ 0.3 सेकेंड्स तक ही किया हुआ है. तो कैसे पता लगाएं फ्रीक्वेंसी कितनी है? 1 बाय टाइम पीरियड. एंड हाउ मच इज 1 बाय टाइम पीरियड है? 1 बाय टाइम पीरियड वुड बी 1 divided by 0.2. So that will be 10 by 2 or 5 hertz. Okay, one oscillation is being completed in 0.2 seconds. So how many oscillations will be completed in 1 second? So we divided 1 by time period and that becomes 5 hertz. Okay class, so we have discussed how sound is produced in the larynx or the voice box of the human. Now we are going to understand how is sound received or heard by the human ear. Okay, so the structure of the human ear, the outer ear is conical in shape and this is also known as the pinna. It collects the sound from the surroundings and this collected sound passes through the auditory canal and reaches the end of the auditory canal where there is a stretched membrane which is also known as the eardrum. Okay, this eardrum starts vibrating as soon as the sound vibrations reach here. Now from these eardrums, these vibrations are carried to the middle ear where there are 3 tiny bones: the hammer, the anvil and the stirrup. Okay, these are 3 tiny bones that are connected and the sound vibrations are amplified with these 3 tiny bones and they are transferred to the inner ear where there is this spiral like structure known as the cochlea. Okay, so this is the inner ear. From the middle ear, these 3 tiny bones called as the hammer, that name has been given to them based on their shapes. Okay, the anvil and the stirrup, their job is to amplify the sound vibrations and these vibrations are then passed on to the inner ear where there is this spiral like structure called the cochlea which converts these sound vibrations into electrical signals and these electrical signals are passed to the brain via the auditory nerve. Now brain helps us to interpret these signals as sound. So this is a simple diagram. I have simplified the diagram. I have not labeled all the other parts or all the other muscles around it. Okay, just the main parts that you require for understanding the block diagram of a human ear. Okay, so I again repeat, pinna, that is the part of the outer ear. It collects the sound. Sound passes through the auditory canal. At the end of the auditory canal, there is an eardrum, which is a stretched membrane, which starts vibrating as soon as the sound reaches it. And these vibrations are then amplified by these 3 tiny bones, which are connected in this manner. hammer, anvil, and stirrup. And these amplified pressure variations are passed on to the inner ear, that is the cochlea, where they are converted into electrical signals, and these electrical signals are passed to the brain via the optic nerve. And brain helps us to interpret the sound as it is received. Okay, next is that how brain interprets the amplitude of a sound, that is referred to as the loudness of the sound. जितना ज़्यादा एम्पलीट्यूड होगा साउंड का उतनी ज़्यादा उसकी लाउडनेस होगी. ओके, रिमेंबर लाउडनेस इज प्रोपोर्शनल टू एम्पलीट्यूड स्क्वायर. सो दैट मीन्स अगर एक साउंड का एम्पलीट्यूड ट्वाइस हो जाएगा तो उसकी लाउडनेस 4 टाइम्स हो जाएगी. अगर किसी साउंड का एम्पलीट्यूड 3 टाइम्स बढ़ाएंगे हम तो उसकी लाउडनेस 9 टाइम्स हो जाएगी. ओके, सो दैट इज द रिलेशनशिप बिटवीन लाउडनेस एंड एम्पलीट्यूड. Loudness is measured in decibels. You must have heard of this unit, decibels. That is the unit to measure loudness. Okay, that you will be studying in higher class. So amplitude is one property which is related to loudness of sound. How brain interprets the loudness means how brain interprets the amplitude of a sound. जितना ज़्यादा amplitude होगा sound का, for example, अगर ये दो sound waves हैं जिनको हमें compare करना है, one is this, okay, representing the distance of the particles from their mean position with respect to time, and another plot of a sound is this. Okay, so you can clearly here make out that the amplitude is greater in the second case. Amplitude is this, the maximum displacement of the particles from their mean position. So that is greater in the second case. So this is a louder sound. Okay, sound 2 is louder. Reason being amplitude is large. Okay. Similarly, another property which is interpreted by the brain for a particular sound wave is its frequency. So, frequency of a sound is interpreted by the brain as the shrillness of the sound. Okay, shrillness, or we call it the pitch. So, higher the frequency, higher will be the pitch. Like for example, if this is sound 1, okay, this is the graphical representation of sound 1, suppose, and there is another sound around which is represented in this manner. Okay, so you can clearly see this sound, second sound, is having a greater frequency. Yes, number of oscillations in a given time is more in case 2 as compared to case 1. So number of oscillations per second is defined as the frequency or the pitch of a sound. So this is a higher pitch sound, or we can say that this is a shriller sound, shriller as compared to sound 1. You say sound 2 is shriller or high pitch. Okay, this is in comparison to the pitch or the frequency of sound 1. Like for example, in daily life also, if we try to relate to this, जो इन्फेंट्स हैं उनके चिल्लाने की या रोने की आवाज़ काफ़ी शार्प होती है, चुभने वाली होती है कान में. ओके, सो वी कॉल इट श्रिल वॉइस, हाई पिच वॉइस. ओके, वेयर जो एडल्ट्स हैं उनकी साउंड थोड़ी डीप होती है, होर्स होती है. ओके, सो दैट इज लो पिच साउंड. Okay, so frequency means number of oscillations per unit time. So more is the number of oscillations, shriller is the sound, higher the pitch of the sound. All right. So if I compare in these two cases, second sound is high pitch or high frequency. Okay, now based on the frequencies of a sound, we can categorize them as audible or inaudible. Or to be specific, for example, frequencies below 20 hertz are termed as infrasonics. Okay, these are the ones which humans cannot hear. All right. For an average adult, the audible range. Okay, we can categorize now sounds on the basis of their frequencies. Frequencies that are below 20 hertz are termed as infrasonics. Frequencies between 20 hertz to 20,000 hertz are the audible range for humans, and the frequencies above 20,000 hertz are known as ultrasonics. So we have here clearly mentioned that 20 hertz to 20,000 hertz is the one range that humans can hear. Below 20 hertz, infrasonics, humans cannot hear. Above 20,000 hertz, ultrasonics also we cannot hear. Okay. The brain can interpret frequencies only between 20 hertz to 20,000 hertz. So that is the audible range. Alright, so next is the difference between noise and music. Noise is unwanted or unpleasant sounds that are present around us, like honking of horns by vehicles. Say in a traffic jam, you can relate to this, that when continuously horns are being honked by the vehicles, so that creates a very unpleasant sound. TV and radio at high volume, okay, that is another example. Students shouting in a classroom is another example. So we can list various examples for noise, all unwanted and unpleasant sounds. Whereas music is defined as pleasant sounds, or you can say melodious sounds. Okay, like sound produced by the musical instruments like sitar, guitar, tabla, etc. When they are played in a particular manner, the sound is very pleasing and melodious. So that is what we refer to as music. Alright, so next topic is a very important concern nowadays, that is noise pollution. Just like we have unwanted gases or unwanted particulate matter in our atmosphere, we call it air pollution. So presence of excessive unwanted sounds in the environment is referred to as noise pollution. Okay. Now causes of this presence of excessive unwanted sounds can be either sounds from vehicles or explosions including bursting of crackers, sounds from machines, loudspeakers, etc. TV and radio played at high volume. Also, some kitchen appliances like mixer, grinders, etc., desert coolers, all these appliances at home, devices at home also contribute to noise pollution around us. Okay, so harmful effects of noise pollution include the various health disorders that it creates, like lack of sleep, hypertension, which is also referred to as high blood pressure, anxiety, and if a person is exposed to loud volumes for quite some time, it can ultimately lead to temporary or permanent hearing impairment. Okay, so lack of sleep, hypertension or high blood pressure, anxiety, and being exposed to loud sound continuously can ultimately lead to temporary or permanent hearing impairment. Okay, now how can we limit noise pollution since it has so many adverse effects? One way is growing more trees, especially along the roadsides, because trees can ultimately behave like sound absorbers. Okay, so the excessive sound that is there that can be absorbed by the trees, and that would help in reducing the noise around. Another way is to install silencing devices in aircraft engines, transport vehicles, industrial machines, and home appliances. So silencing devices can also help in reducing the noise pollution. Okay, some other ways to reduce noise pollution. All noisy operations must be conducted away from residential areas. Okay, like all the get-togethers, the family functions that are there, uh, like marriages and all, they should be conducted away from residential areas, which are noise-making operations. Then noise-producing industries should be set away from such areas. Okay, and use of automobile horns should be minimized, and TV, radio, music systems should be run at low volume. Okay, so these all steps can help in reducing the amount of noise reaching the residential area. So a few steps that can be taken up to reduce the amount of noise reaching the residential areas. Alright, class. So finding the time period and frequency of a pendulum that oscillates 120 times in 14 seconds. Also, you have to find if the sound will be audible or not. तो टाइम पीरियड क्या होता है? टाइम टेकन टू कंप्लीट वन ऑसिलेशन. ठीक है, अब यूनिटरी मेथड फॉलो कर रहे हैं हम. 120 ऑसिलेशन हो रही हैं कितनी देर में? 120 ऑसिलेशन आर टेकिंग प्लेस इन 14 सेकेंड्स. वन ऑसिलेशन कितनी देर में होगी? 14 डिवाइडेड बाय 120 seconds. ठीक है, so this will give you the time period of the oscillation. Okay, Now when we calculate, obviously you are not going to leave the answer like this. You will be leaving it in decimals. So this will come out to be 0.11 seconds option. Okay. थोड़ा नॉन टर्मिनेटिंग डेसिमल है बट आई एम पॉजिंग इट एट आई एम टर्मिनेटिंग इट एट द सेकंड डेसिमल. Similarly, frequency क्या होता है? How do we define frequency? Frequency is the number of oscillations per unit time. Number of oscillations upon time. तो कैसे कैलकुलेट करेंगे हम? नंबर ऑफ ऑसिलेशन कितनी है? 120. टाइम कितना है? 40. इसी का रेसिप्रोकल है. या तो आप सीधा 1 डिवाइडेड बाय 0.1 कर दो, 0.11 कर दो, या फिर आप 120 डिवाइडेड बाय 14 कैलकुलेट करो. बात एक ही होगी. ठीक है. सो 120 डिवाइडेड बाय 14 विल बी 8.57 hertz. Don't forget the units. Okay. So this is the time period of oscillation. Time period is 1.11 seconds and frequency is coming out to be 8.7 hertz. Now you have been asked, is it audible or not? Is this sound audible? So what will be your answer? No, this sound is not audible. Why? Because it is not falling in the audible range. This sound is inaudible. क्यों? क्योंकि ऑडिबल रेंज कितनी है हमारी? 20 हर्ट्ज टू 20,000 हर्ट्ज, या मैं 20 किलो हर्ट्ज लिख दूँ, एक ही बात है. ठीक है. 20 हर्ट्ज टू 20,000 हर्ट्ज इज द ऑडिबल रेंज एंड दिस इज बिलो 20 हर्ट्ज. सो दिस इज इंफ्रासोनिक. रिमेंबर हमने लिखा था, वी हैड कैटेगराइज्ड दिस साउंड. दिस इज एन इंफ्रासोनिक साउंड. इट विल नॉट बी ऑडिबल टू ह्यूमन ईयर. ठीक है. So this is how you judge if a given sound is audible or not. अगर क्वेश्चन में ये पूछा है is this sound audible or not, how will you judge? You will judge it on the basis of the frequency. If the frequency is lying within the audible range, it is audible, otherwise inaudible. ठीक है.